What's up, Pre-Cal 12? This is our podcast 2.2. Yeah, we're getting started here. Working in class and then we get started.
That's for the white. Okay.
Or it's just negative.
Wait, what did it be? 16 plus? Coach, talk to me.
Yeah.
32 plus. Okay.
Yeah, because I was going to say, negative 2 is just
Four.
Good?
Probably go by.
Great. Yeah.
Alright, I'm gonna go forward.
That's the wide intercept.
Oh, it's
So
this.
Yeah, so this is actually 4 common there, right?
Yeah.
This y-intercept though.
Like 0.
I thought we could
It bounces off the
That's so this right here, 4 comma 0 is different than the y-intercept. So you can just but this is the y-intercept. That's what it is.
Oh, so we put 0.
Yeah, that's it. So that would be.
Going back on the
If you're doing y-intercept.
Which we did, right?
What's up? Good to see you, Victoria.
Yeah.
Get my text.
Yes, I did. I've heard it.
Yes, that works for me. Yeah,
Yeah.
like,
Okay.
right.
Thank you.
Where is that?
Oh, no. Plug in.
I think it was positive. The reason why is when you did negative p over 2a, it was already negative, so then it would make it a positive.
We plugged the 4 to find this.
Which happens to actually be the same
Are you
as.
serious?
If you ended up doing, you actually do get the same. Just be sure to go to the negative p over 2a to find the vertex.
David, how do you get the y? You have to, okay, so you have to plug in 4, you have to plug in 4 on there to find the y. Then once you find the y, you plug in the 0 to find the y.
So you plug 0 into what?
You plug 0 into that.
4 times
So
negative
weird.
8 is the x.
Yeah, you plug 0 for x, and that's how you find the y.
And that would be,
Yeah, we plugged in 4 for x, that's how we got 0.
No, because I already did.
So we 0 squared minus 8 times 0, so we 16.
but you're right here. Add and subtract that, and you'll get the right answer there. That's
Now
great.
we have to grab that.
Good job, y'all. Good work.
Do it.
David, y'all get 16? Yeah. Wait, Coach Jay, do you just have some graphic paper? Cause
Is it a little harder to do that, or to just write it? I can get some graph paper.
Not for your.
I'll tell you what, I'll get it for.
I have to bend down on this board.
I know where you're going with that.
No,
I know where
no,
you're
Jack
going.
said the joke
I
though.
know where you're going. All right, hey, let's do this. Are we good on the graph? Hey, David, that's fine. We can just do it up here, and I'll probably ask questions just to see if you got the graph from there to the graph. Was there any part of that you struggled with, Audrey?
What is that odd multiplicity?
Great question. I'm going to address this today. It's kind of a part of the lesson. I'll do this. This is not for like right now. It'll be related to what's up here. Sound good? So let's go through each part, and maybe that'll help us. The zeros of the polynomial. Those are the x-intercepts, right? What did we do to find the x-intercepts?
Factor.
Yeah, good. And how did you factor it, Dave?
I got x minus 4, x minus 4.
Good. X minus 4, you could have said x minus 4 squared, but that'll work. And that would be the zeros of our polynomial, which would be?
4.
4. Yeah, 4 comma 0. So make sure you give it to me, 4 comma 0 in that spot. Good. State the multiplicity. Diego, do you remember what the multiplicity would be?
2.
Good. Why is it 2?
Because you plug in 4. Because it happens twice.
Yeah, because there's 2 times it occurs, right? Traditionally it's 1, but sometimes it'll happen like this where there's 2 or multiple ones that are there. So this has a multiplicity of 2. So we're going to go here, 1, 2, 3, 4, boom. Someone help me that hasn't gotten a ticket yet. The vertex is going to be what type of extrema, or what type of vertex? Victoria, do you know? A minimum. Good. Do you know why?
Because it's a positive.
Good. It's positive. It's going up, and therefore it will be our minimum that's there. Good. Didn't ask that, but I thought that was good. The vertex What would be the vertex here? How do we find that? Good, yeah, the formula here is negative b over 2a. I'd get that on our note card, by the way. And then comma, f of negative b over 2a, which just means we plug in this value in to find what the y is. Now, when we get negative b over 2a, did everyone get, Hannah, what'd you get again? Did everyone get 4?
Yeah.
Everyone's good? And when you plugged it in, what'd you get out? 0. Why is that a little weird? Maybe a little different. Maybe it's not different for you. What do we know about the zeros and the vertex? They're the same. Yeah, they're the same. So that may sometimes happen. Does anyone know why that happens in relationship to my multiplicity?
Because there's 2 of them, it's gonna mimic.
Say that again?
Since there's 2 of them, it's gonna like mimic or be the same. Yeah.
Not necessarily, but that's a good thought. Kind of, sort of.
Versus 2, the 4s mimic, there's gonna be 2 4s.
If it's 2 4s, if the multiplicity is even, and this is where we're coming to this, Audrey, compared to odd. If it is odd, what happens at the x-axis? At the x-intercept. What's up, Jake?
They go different directions.
Doesn't go different directions. It's going to go through it. Okay? If it is even, it is going to bounce. You say, Coach, what are you talking about? Well, let's do this. What's the y-intercept here? 0, 16, right? Because I'll plug 0 in for x to get that out. Good. So this is 0, 16. So I'll do that, 0, and then it goes way up to 16. I mean, it's way up here. Do we need a t-chart for this? Probably, just because it's like way up there. So maybe I'll plug in 2 in for this. What's 2 squared?
4.
Good, minus
16.
minus 16 plus 16. So what would this be as my output when I plug in 2 for my t-chart? 4. So I'll go 2, 4, and then just mirror that over 2 to the right of 4. And what I can do is do something that looks like this. What do I notice at that vertex or at the spot where it hits?
Bounce.
It bounces. And what's the multiplicity there, Jack?
2, so it should go through.
No, it's actually, so when it's odd, it goes through.
Oh, yeah.
When it's even, it's going to bounce. Got me? So when you have an even multiplicity, so like at 4, it has an even multiplicity, it's going to bounce on that x-axis. And when it's odd, it's going to actually go through it. Okay? So it's going to go through. I'll be honest, that's a really good thing for the note card. If I was keeping it, if I was tracking that, that's what I would do. Okay? Questions on that? Good stuff. Hey, I would take out your home. Yeah, standard note card.
One-sided or double-sided?
Yeah, we'll do one-sided, just because it's a quiz and stuff. So,
Would you let us read the final exam using the card?
I don't know.
What a homemade note card, like printer, like John's poster.
Like a poster, just bring it in.
Mhm.
We'll see. Do y'all say yes?
Yes, Coach
Yeah.
Jay.
We'll see. Let's see. See what we can do. All right, hey, do this. Take out your note card, or not note card. Well, you could. Take out your homework real quick. We're going to go into this next stuff. If you want to, you can take out your phone and take a picture of this. If you want, you do not have to do this. This is not required. Not required. But if you desire to get bonus on the quiz tomorrow, these 5 questions are good ones to practice on. And then also I'll give you like +2 or +3 on the quiz tomorrow if you attack it. So if you have any questions on it, go ahead tomorrow. Come in tomorrow morning. Now I'll do a little review session over that as well. Okay? Those are good stuff to review on. Cool. Okay, let's talk about this real quick. X squared minus 25. Okay, some of this is just simply notes. There's a lot of these that are homework problems. So I would just get out your homework. There's a couple that I'll do the same thing where we'll collaborate together and just see how far we can go. But just as a reminder to us, how do I find the zeros? That's the first step. How can I find the zeros of x squared minus 25? Jake?
Wait, are you just gonna factor it? And then
Good. Yeah, so how could I factor that?
X plus 5 is 9.
Good. X plus 5, X minus 5. Nice.
Negative 5 is 5.
Good. And why did you do that again?
Because you said it was 0, x plus 5 equals 0, x minus 5 equals 0.
Good. Remember, x-intercepts, we put it equal to 0. We set it equal, and we get x is equal to negative 5 comma 0 and 5 comma 0, right? Pretty easy, right? We did this. The one thing, I just want to make sure we're all clear on what we just talked about. What is the multiplicity of negative 5, 0 and 5, 0? Katie, do you know?
They're both 1.
Yeah, they're both 1. So on the test, here's how I would do it. I'll understand this notation. If you put M1, we'll make it a little Michigan M for us. M1 or multiplicity, you actually write it out. I'll understand that. So if you want to do it, that's A-okay by me. But each of these have a multiplicity of 1. Now, someone help me with what we just talked about. Actually, Audrey, I want to see if you got it. How does that impact my graph at each of these two x-intercepts?
It goes through.
Good. Yeah. How does it go through? Does it go through one or both of them? What do you think? You're right. You're exactly right. It does go. Goes through both. Good. So just know that it's going to go through both because each of them have a multiplicity of 1. Good. How do y'all feel on that?
Good.
Gucci on that?
Gucci.
Okay, here we go. Next part. Let's go to this. This is a homework problem, number 3. We're going to do all parts of this, and we're just going to extend that just a little bit to polynomials outside of just x squared. So this is where we're going to kind of dive into this.
Wait, which one is this?
Part 3 should be on the back side. Is that right?
Oh, yeah.
Did we do this one already?
It's on the last page.
No,
Excellent.
it's on the very back.
Yeah.
Oh, it's on the very back. That's my B. That's my B. I was mistaken. Okay, so here's the kicker. I want you in your groups to do a couple of things, okay? Go ahead. I just want to see how far we are. Find the zeros, determine the multiplicity, and then using a graph to graph and verify your answer, here's all I need you to do. I just want to make sure you know how to plug this in and get it on your graph. Get it on your calculator, okay? So if you have one person in your group do it, that's A-okay by me. Also, I want you to do one other thing on the side of this, okay? I want you to find the end behavior. Do you remember this from Friday? Do you remember this? If it's odd positive, odd negative, even positive, even negative. Do we need to review that real quick?
Yes. Wait.
2 seconds.
Yeah, just like.
Okay. All right, here we go. Ready? If it's even, we're talking about the degree of the polynomial, right? The highest exponent's even. They're both going to go together, right? So we're talking lead coefficient, the number in front of the highest degree. If it's even positive, what is it going to do? Even positive. Even negative does what? Goes down. I have to do it this way because I mess up. Odd positive does what? Right here, right? And odd negative does what? Right here, left hand goes up, right? So remember that when you're using this. Cool? I'm going to give you, again, about 5 minutes just to practice this, and we'll come back, and I just want to make sure that you're good on this as well, okay? Just in case you're messing up or if you're confused, what do we pull out first when we find the zeros?
X squared.
X squared, right? And then we can go ahead and factor. Cool. Let's go. First
You have a
two.
question?
Yes, sir.
So, how do you
Zero, 5, and negative 4 for the
Exactly right.
zeros.
And how many? What's the
5x
multiplicity
squared
of
and
that?
9 factors x squared minus x minus 2.
Wait, we pulled out an X squared.
Yeah, because of all of them x squared.
So it'd be x squared.
And then parentheses
X squared.
x squared minus
X squared.
Is it twice for the X
Yeah.
squared?
If it has an exponent, that gives us a hint.
Oh, so if whatever the exponent is that cue the negativity or what?
Multiplicity.
Multiplicity?
That's exactly right. Yep. That's exactly right.
Squared, and then you would parentheses.
Yeah, Coach Jay.
Yes.
What's the little symbol that you used to be able to do for negative? I mean, multiplicity.
That's like around the next thing.
Like I thought you said you didn't see it, but this was sign.
X with x minus 5.
So like we put it in brackets.
I've never used
That's all right. But if I do like, if I just do like mulch,
I'm gonna
I would just say like x equals 0. I know what that means. That means it's the x-intercept. And just put m1.
Got it.
M1. I'm good on that.
But is graph going up, like both up? 'Cause
So then you just put this on the calculator because they only have like one. If you like center equals 0.
So what's the
only
difference?
one x minus 1? Yeah, there's only one x
Good.
minus
Yes, they're both going up or down. And since it's positive, that means that both are going to go up, right? So I go positive even, negative even. Positive odd, negative odd. I don't know what that helps. Yeah, that's so both go.
Yeah.
Both ways.
Right. No, I'm not like rude. Clear both.
Kashu,
Yeah.
I'm a little stuck on like how you start with the graphics. I found like the zeros and the multiples.
I finally remembered. I got it this morning. I was like,
The number of turning points of the graph.
not really. I didn't do it.
Or you're just saying how to put it in the calculator? Is that
Yeah,
right?
yeah. It says use a graphing utility to graph and verify your answer. How would I do that?
Go ahead to y equals that top left right there. And then I would just plug it in the way you see. The only thing that you'll have to do is that caret right here, for like x to the fourth.
But then I still have to see this I square by that.
So we plug in the first equation later.
I guess it is.
And if you are, it's not maybe I should.
Yeah. Oh yeah. It is good.
Alright, and then we did that with graphing.
Got it?
Correct.
Is that what yours looks like? Is that what yours looks like?
Yeah.
It might look weird.
What party people made that one?
Yeah, you can go to Zoom. I always go to Zoom or Zoom standard first, maybe like 6 1 just go to 10 by 10 there. I'll give you just a couple more minutes to kind of try that out.
Second trace. Zoom standard. Oh, when it's
That's
just
it.
And I could even back it out. You're gonna see me kind of there here in a second. I would like you to zoom out and then that bottom's kind of weird. But that would be right. Nicely done.
Kashu, we would have to write down like it says like just use a graphing calculator to verify your answer. That's high.
Yeah, you're good. You're good to go. Awesome. All right, let's take a look. Oh, hold on. Give me like 30 seconds. Cool. It goes off the amount of multiplicity. That makes sense. So how many times it except
What?
why? Has to do with the squares or how many times it moves. Does that make sense? As being 2. Because you could do x. It's like the same as saying like x times x times. Does that make sense? There's 2 lines. No, you do. You did that perfectly. But and it's not even plus or minus. It just means that there, because it's squared, that means it happens twice. Does that make sense? That means that there's 2 there.
So I could write it plus or minus just to make that
You can. I would just say in my head, if it's squared, I know that it happens 2 times, or there's 2 times that 0 is a solution. That or could be a solution. Right? Maybe it will help on this. Maybe when I like graph it, I think that might help. Okay, hey, this part right here, probably one of the more important things of what we're talking about today, okay? We're going to go into, again, some more homework ones, and I hope this is helpful as we're doing homework together, but I think that this will make sense when we wrap it all together on the zeros and that sort of thing, okay? All right, so we set it equal to 0. I think we're good there. Diego, what do we do in order to solve for the zeros on this? What'd you pull out first?
X squared.
Nice. And we set, what were the factors?
Minus 5.
Good, Ian? Good. I want you to look up here real quick. Is everyone game on this right here?
Yes.
What are the zeros, the actual zeros? 5, -4, and?
0.
And 0. Very good. So we've got to say that this is going to be, we'll do this. This one is 0. Don't forget that, okay? So this one is 0. So x equals 0, 5, and negative 4, right? These are all three solutions. Now here's where we come into play. What's the multiplicity? Someone raise their hand and tell me. What's the multiplicity of each of these?
2.
Sorry.
2 for 0.
Multiplicity of 0 is 2 because it repeats twice. Look at the exponent. The multiplicity of 5 is 1, and multiplicity of negative 4 is 1 as well because it only repeats once here. Okay? Alright? Alright, question. Jake, what if this was a 4? What would be the multiplicity? 4. Do you see that? So it has everything to do with what is the exponent. Okay? Alright, so question. What's going to happen at each of these? Can someone just tell me real quick as you remember from what we just talked about? What's going to happen at each of these three for the graph? What could we expect? Bounce it, 0, good. Go through 5 and go through negative 4. Good, Mason. Exactly right. Is everyone okay on that?
Yeah.
All right, so what if I didn't have a calculator? That was good, David. What if I didn't have a calculator? How could I graph this?
Put your T-chart.
Okay.
T-chart.
It's going to be, we could, what would be the y-intercept?
So
I'll give you 4 tickets if you can raise your hand and tell me what the y-intercept is, Rosemary. Negative 20, that's a good thought. That's a good thought there. Jake, do you know? Okay, someone raise your hand and help me. What is the, Audrey, do you know?
0.
It's 0, good. Remember y-intercept, we plugged 0 in for x, right? So if we did that, we get 0 minus 0 minus 0 is equal to 0. So remember that when we're talking about x and y-intercept. Great job. So if I were to graph this, here we go. Again, you don't have to do this. I'm just showing it to you. But remember, keep this in the back of your mind. All right, right up here. Y'all got it? Jake, Rosemary? When I do this, I've got 0. I've got 1, 2, 3, 4, 5. And I've got negative 4. Okay? Now, once I get my zeros question, what do I know about my end behavior? Someone just raise their hand. Help me with what we've got on end behavior. Hannah?
you know, 1 is like at the 0, it's gonna balance, and then it's gonna pass through 5 and 4.
I like that. So I'm just going to put B for bounce, and this is going to be G for go through, right?
Right.
What about my end behavior, though?
Oh, they're both gonna go up. Sorry.
Good. They're going to finish at the end. We don't know what's happening in the middle, but it's going to finish on the ends, right? Because it's positive and even, right, on that side. So what I'm going to do is just on the furthest left, it's going to rise to the left, and it's going to rise to the right. Are y'all good with that?
Yep.
Okay? So what's going to happen? Well, it's going to come where? To this first 0, and what's going to happen at that 0? It's going to go through. Nice.
Yeah.
When it hits, now I will say this, how far it goes down, I would use a T-chart if I was actually doing this. So I would plug in like negative 2 in and like see how far down it goes. That way you've got somewhat of a minimum. But it's going to hit a minimum value and that's going to come up. What's going to happen, Hunter, at this one? What's going to happen at that 0? Is it going to go through or is it going to bounce back? Oh, I was asking you.
I don't know what James is he gonna bounce?
Yeah, it's good. Yeah, exactly right. So you're going to bounce. It's going to return, right, because it has an even multiplicity. It's going to come down. Again, I don't know how far. You'll have to use a T-chart on that. But once it hits the bottom, it'll hit the bottom somewhere. And once it comes back, what's going to happen at this x-intercept? It's going to go through because it's got to finish towards the right. Do y'all see how you did that? You just graphed this. All right? I don't think y'all did that last year, did you?
I don't even think it's now.
Take it. I don't think that's on there, though, the graph.
Wait, did you use that?
I did, yeah.
So does it matter how far down you go?
Great question. For right now, in the let's say we do a polynomial on the test. Here's what I would do. The only thing that I didn't do that I would expect you to do on the test is to create a T-chart where I would just find out how low did I go right here, right? Like maybe plug in negative 2 right there. And the same thing holds true. I can maybe plug in 3 or something. And that way I have an idea of approximately how low I went. You could also use your calculator and then solve for what the minimum would be here by going to your calculator and plugging it in. Okay. All right. How do y'all feel? Y'all feel Gucci?
Yeah.
Everything good? All right, here we go. Go to this next one. Go through A, B, C, and D again. I want you to actually graph this one. I want you to try to graph this one. So go ahead. Could I back up just a second? What is the degree of this polynomial? This is kind of tricky. Raise your hand if you kind of have an idea. David, do you know?
When you say degree, like up and down, all that stuff? Like, will it go up?
The highest degree is the highest exponent. So if I were to get the highest exponent of this polynomial, what would it be? Go ahead. You're good.
2.
It's incorrect here. Jake, do you know?
4.
Be 4. Good. And that's because it's factored out. Do you see that? If I were to multiply it out, it would be both positive and it would be to the 4th degree. Cool? All right, right now, amongst yourselves on this homework, go ahead and go through each parts of these. I think I apologize. I don't know if I gave you enough room on that. Maybe below. Maybe below there. Good question, because if I were to multiply this out, right, it would be x squared. I'm not going to, because it's already there for me. But it would be x squared times x squared over here, where the highest degree or highest exponent would be to the 4th power. Does that make sense? Remember on the previous one, when we factored it out, we got something that looked like this. I think I got the signs wrong, but we'll go with it. This right here, you wouldn't say, well, that's a 2nd degree polynomial. No, because remember, we factored it. In the previous part, you notice that, is x to the 4th, right? When it was in standard form. So what we would have to do is just in your mind say, there's 1x, 2 x's. I add them together, that is x to the 4th. Cool? Good. Audrey, you're good on that part with the multiplicities.
Yes.
That one. And then 1/5. Does that have doesn't. There's no x, right? And you did that perfectly. If you showed that, you would get it wrong. Exactly right. Exactly right. Good. And then I would go end behavior, right? Like kind of how we end up, like where is an ending? Up, down, left, Once I know the end behavior, that will help me in knowing like where it's going. Does that make sense? But you're right. You're exactly right on that.
Okay.
Good stuff. Yeah, Dave?
I'm trying to figure out if my 0 is
Did perfectly. Good stuff.
Christian, I don't know where to start.
What part?
Where do you start?
Right here? Yeah, well, it's already factored for us, right? So it's kind of nice. We just simply set them equal to 0 to solve for the zeros.
Okay.
And what would the multiplicity be? I'll let you find those zeros first.
X plus 2 equals 0.
Are
What do
you
you do with
talking
squared?
Good question. I would just leave it out because we're just saying what makes that 0.
Okay.
And in that case, it would be x is equal to. Good. And then the second one would be -2. Great. So once we know that those are our 2 zeros, what's the multiplicity?
They're both 1.
I think this is where maybe we were struggling
Oh,
earlier.
it's 2.
It's
For
2
both.
because of the square, right?
Okay.
Good.
And then half, or 1/5 equals 0.
And that one, since it doesn't have an x, you're good. You can just drop that.
Just drop it?
Mhm.
So what do we do now?
Now, once we do that, we can plot where the points are, right?
Okay.
Cool. So we can go to -2, and 5/3 would be 2 and 5/3. Each has a multiplicity of 2. 5/3 would be like right in there, right? And so once I know that, what's going to happen at each of the zeros here? They're going to go through or they're going to bounce?
So it's even, so it's going to bounce.
Good. Yeah, so these are going to bounce here. And what is my end behavior?
I found this in my car.
Even.
Twenty is positive.
Odd.
What are your 12
Even positive.
Great, good job. So then,
What number do you go off of for?
the positive part or the even part?
So this is even.
So because we multiply two x's together, right? X squared and x squared, we simply add these two to say, oh, that the highest power would be to the fourth,
Where
right?
did you multiply this together?
Why wouldn't I?
No, where did you? The x.
To get to the fourth power? Well, you don't need to know the coefficient per se, like the number, but you just know that if I were to take this and distribute it out, the highest exponent would be x squared, and the one over here, the highest exponent would be x squared, as I distribute, right? So if I were to add those two together, then this would be x to the fourth as my highest degree. Look over here. The highest one would be x squared if distributed, and over here, you don't have to do this, but the highest would be x to the third. Therefore, when combined would be x to the fifth. Very good. Very
So
good.
this one you just did.
That one
Highest is 4.
correct. That's easy right there. That one's easier to see.
So this is factored form?
Correct. They factored it for you to make it a little easier for when we're learning this. That's good. Yeah.
Coach, how does this look?
Yeah, it's AGA, but then I was like,
Doesn't make sense.
I just think it's gonna be
Makes
college.
sense. It's really good. How did you get the 20?
Plug the 0 in.
4?
2 zeros, what do you do?
X.
You find the y?
There's no way you do that.
So you plug in 0 for x.
Like that. Pull X right here. Same 0. So go back to the put 0.
I was looking at it.
I'm going to show too as we're dissecting.
There's not, you also do A too, I guess.
Go ahead, yeah, get it done. Hey, if you're done with that one and you feel good, go ahead to the next one to the right of it, okay?
Is this not out?
Yeah. Yeah, that's perfect. Perfect. Can I do this? Can I do it on the board?
Because if it's like
So,
what are the
Negative
denominators?
2 and 5/3,
So
you did that
3 over
perfect.
3
Got
would
me?
be 1.
Hey, if you're struggling, if you're good, go to the next one. If you're struggling on the graphs there, go ahead and just give me your eyes and attention just so that we can kind of talk this through. So I think everyone's good on the fact that we have the x-intercepts and the multiplicity. I think everyone probably, I could be wrong, know that this is going to bounce at both spots, right? We know that. So what we're going to do is we're going to put a dot at negative 2 and 5/3, okay? Does that make sense? I think you all had that, David and Victoria. So then we go to the lead coefficient test, which tells me what is the end behavior. Now, when multiplied out, I know it's not, what would be the highest degree? And this is a little tricky. The fourth, because this would be x squared and x squared. So the highest degree would be x to the fourth. Would it be positive or negative in front of it? Positive. Very good, because look at that 1/5 as well. That's a key. So positive x to the fourth. So where would I finish up? Up, down. What do you think?
Up. Wait. Yeah, up.
Up, right? Yeah. We're going to rise to the right and rise to the left. Okay? I'm sorry, I should go upwards. My fault. Go up, to the left, and to the right. Okay? Now, question. David, when it comes down here, or Victoria, when I hit this x-intercept, what's going to happen?
Bounce.
It's going to bounce upward, right? And when I come back here, because it's coming from the right, what's going to happen on this side?
Bounce.
Bounce. So there's only one way to connect this, right? And that's to be able to hit like a little maximum up here somewhere. Where it is, that's where we've got to find it. But we know that we could probably find it pretty close by finding the y-intercept, right? Or maybe doing a t-chart. But if I found the y-intercept, I plug 0 in for y-intercept, we plug 0 in for, who said that? X. Very good, Rosemary. And when I plug that 0 in for x, we can get out what the y-intercept would be there, okay? David, Victoria, are we okay so far? Okay?
Wait, Coach, it bounces as even, right?
Correct, exactly. So because they're both even, right, right here and here, we know that it'll bounce on each of those. The question is how high. That's the only thing. So if I plug 0 in for x, I get 0 plus 2 squared is 4. So this would be 4 times 1/5. This is 0 minus 5, so that's -5 squared. 25, right? What'd you get there, Olivia, when you...
For the y-intercept, 0.20.
Good, yeah, so 0.20. I know this isn't like to scale, but what we could do is just say, hey, this is going to be at 20. I know it's not perfect, and I'm fine with that. I come down, I hit at this spot, and there's only one way to kind of join this, and that's to hit about, it's approximately a maximum at around 0.20. It could be off just a little, but ideally it's pretty close.
How would a degree of 5 like fall? How would that go?
Yeah, so the next one's a degree of 5. It's positive. I think it's positive,
Yeah,
right? So it's not going to go here and here, but how's it going to end up?
It's gonna rise right, fall left.
Rise right, fall left. So just know that that's the end behavior. Cool? All right, how did this feel? Y'all should feel smart for this. This is tough stuff. Pretty good. Y'all picking it up good. Okay, I think we're good. I think I've got like literally how much? I think it's almost literally it's time. Here's the only thing I need you to look at, okay? Tomorrow on the quiz, there's one problem that I didn't quite hit on. It's not hard because we had one on the homework on the first section. Remember this 53? If these are the zeros, how could I factor that out? Like, if I were to say, all right, these are the zeros, how do I factor it? This would be x times
X plus 2.
x plus 2 and
X plus 3.
x plus 3. So the only thing I need you to know is this. Distribute these last two, right? So like distribute it out, x squared plus 2x plus 3x plus 6. And then multiply by x, because we didn't use that yet, to each of these parts.